Testing airplanes to ensure they are safe at cruising altitudes, such as 37,000 feet, is a highly complex and rigorous process. Safety is the top priority in aviation, and multiple testing phases are conducted to make sure that aircraft can handle everything from extreme weather conditions to mechanical failures. Here's a look at how planes are tested to keep us safe when flying at high altitudes. 1. Design and simulation. Before a plane ever takes off, extensive computer simulations are used to test how the design will behave in various conditions. 1. Aerodynamic testing. Engineers use computational fluid dynamics, CFD, to simulate airflow over the plane. 1. This helps in understanding how the aircraft will respond to different weather conditions, including turbulence, strong winds, and crosswinds. 2. Flight simulation. Advanced flight simulators replicate real-life flying conditions, including emergency situations. 2. Pilots use these to practice maneuvers like engine failure or loss of control, helping them understand how the plane will behave in extreme scenarios. 2. Wind tunnel testing. Wind tunnel tests are a crucial step in the design phase. Scale models or full-size aircraft prototypes are placed in a wind tunnel where air is blown over and around them. These tests can simulate high-speed airflow, turbulence, and even dangerous weather conditions like severe crosswinds and gusts. 1. Testing structural integrity. Engineers examine how the aircraft's wings, fuselage, and control surfaces behave at high speeds and different altitudes, ensuring that it can withstand extreme pressure and wind forces. 3. Ground testing. Before any flight testing, the aircraft undergoes rigorous ground tests to ensure all systems are working properly. 1. Engine tests. Each engine is tested for performance and durability. 1. This includes running the engines at various power settings, including takeoff, cruise, and idle, to check for consistency and reliability under extreme conditions. 2. Pressurization tests. The aircraft's cabin must be able to safely handle the pressure differences between the inside of the plane and the outside atmosphere at cruising altitude. 2. Engineers perform static tests where the plane is pressurized in a controlled environment to simulate the conditions at 37,000 feet and verify that it holds steady without leaks. 3. Flight control systems. All flight control systems, for example, ailerons, elevators, rudders, and flaps, are tested on the ground. 3. This ensures that the response to pilot commands is accurate and reliable in all conditions. 4. Flight testing. Once the aircraft is deemed ready for flight testing, a series of tests are conducted to verify its performance and safety. 1. Low-speed tests. Initially, test pilots fly the aircraft at low speeds, checking its handling characteristics during takeoff and landing. 1. They test everything from stability to braking effectiveness. 2. High-speed and high-altitude tests. Test flights at high speeds and altitudes, up to 40,000 feet or more, allow engineers to assess how the aircraft handles under real-world conditions. 2. They look for stability, handling, and fuel efficiency at cruising altitudes. 3. Emergency procedures. A crucial part of flight testing is simulating emergency scenarios, such as engine failure, cabin depressurization, or rapid loss of altitude. 3. Pilots practice emergency maneuvers to ensure they can handle these situations in real life. 4. Structural stress tests. During flight, the plane is subjected to stress tests to simulate the pressure and forces that it would encounter during turbulence, severe weather, or unexpected maneuvers. 4. This includes intentionally stalling the aircraft to see how it recovers and testing its ability to withstand extreme G-forces. 5. Software and system integration testing. Modern planes are heavily dependent on software, from autopilot systems to engine monitoring. Therefore, testing how the aircraft's computer systems interact is critical. 1. Autopilot and navigation systems. Testers ensure that autopilot systems can perform in all phases of flight, from takeoff to landing. 1. They also test the aircraft's navigation systems for accuracy, ensuring the plane can fly safely and reliably at high altitudes. 2. Flight management systems, FMS. These systems help pilots manage everything from route planning to fuel consumption. 2. Extensive testing ensures that FMS can adapt to changing conditions in flight. 3. Avionics. The aircraft's communication, navigation, and radar systems are tested to ensure they function properly at high altitudes, where clear communication with air traffic control is critical. 6. Endurance testing. Some aircraft need to undergo long-duration testing to ensure they can handle long-haul flights. This often involves flying for several hours or even days at a time, testing everything from fuel consumption to cabin pressurization. 1. High altitude and low temperature. Planes are flown at the highest cruising altitudes to see how they perform in the low temperatures and low pressures typically found at 37,000 feet. 1. The aircraft must maintain functionality in these extreme conditions, including engines, avionics, and cabin pressurization. 7. Regulatory approval. After all the testing is completed, the aircraft must go through a rigorous certification process by aviation authorities such as the Federal Aviation Administration, FAA, in the US or the European Union Aviation Safety Agency, EASA. 1. Certification flights. The aircraft must undergo certification flights where inspectors and engineers verify that it meets all safety and regulatory standards. 1. These flights ensure that everything, from the engines to the landing gear, functions perfectly. 2. Compliance with standards. The aircraft must meet the rigorous safety standards set by aviation authorities. 2. These standards include everything from structural integrity to fuel efficiency and noise levels. 8. Post-certification monitoring. Even after an aircraft is certified and in service, it undergoes continuous testing and monitoring. Airlines and manufacturers collect data from every flight to detect any potential issues early. 1. In-flight data monitoring. Modern aircraft are equipped with sensors that constantly monitor systems like engine performance, fuel efficiency, and structural integrity. 1. This data is sent back to the manufacturer or airline for analysis and to detect any potential issues before they become major problems. 2. Maintenance checks. Regular maintenance checks are required at set intervals to ensure that the aircraft continues to meet safety standards throughout its operational life. Conclusion. Testing aircraft is a multi-step, multi-year process that involves everything from computer simulations to real-world flight testing. The safety of passengers is paramount, and the aviation industry invests heavily in ensuring that every plane, whether it's flying at 37,000 feet or taking off from a runway, is ready to perform safely in all conditions. Through these rigorous testing phases, modern aircraft are built to be resilient, reliable, and capable of handling the challenges of high-altitude flight.